Hello everyone, this is Zakwan from class JCS 1102F. So in this video, we're going to talk about application of differentiation. Let's get started. First, we need to know the meaning of differentiation. Differentiation is the instantaneous rate of change of a function with respect to one of its variables. Or, differentiation is a process of finding the derivative or rate of change of a function. Did you guys know why we use differentiation? Let me tell you guys, we use differentiation because it can help us solve many types of real-world problems. We use the derivative to determine the maximum and minimum value of particular function. For example, cost, strength, amount of material used in a building, profit, loss, and so on. To make it clear, differentiation have application nearly to all quantitative regulations such as physics, geometry, algebra, and many more in mathematical field. Now, we're going to talk about our subtopic, which is related rates.
Hi guys, it's me Zahid from JCS 1102F, and now I'm going to explain you guys some examples for differentiation.
For now, we're going to talk about related rates. First example is about making of coffee. Coffee is draining from a conical filter into a cylinder coffee pot at rate 10 in 03 per min. The second example is falling ladder. So I've got a 10-foot ladder that's leaning against wall, but it's on very slick ground and it starts to slide outward. And right at the moment that we are looking at this ladder, the base of the ladder is 8 feet away from the base of the walls, and it is sliding outward at 4 feet per second, and we will assume that the top of the ladder kind of glides along the side of the wall. It stays kind of in contact with the wall and moves straight down.
So, let's figure out the problem statement. A baseball player is running second base to third base at a speed of 20 feet per second. He is currently 50 feet away from the third base. The baseball field has the shape of a square with a side length of 120 feet. At what rate is the distance between the player and the home plate changing? So, we have a baseball base where there is first base, second, third, and home plate. So, the player is somewhere between second and third base, and he moved to third base at a speed of 20 feet per second, and he currently 50 feet away from third base. The side length is 120, so every side of this field is 120. So, we want to focus on the rate at which the distance between the player and the home plate is changing. So, notice that we have a right triangle. Let's call this X, Y, and Z. So, this problem is to determine the rate at which Z is changing. So, we need to calculate the Z dt. First, we have the value of X is 50 and we have Y is 120, but we don't have the value of Z. So, we figure out the value of dx dt is which negative 20. So, we have a triangle which is z square equal to x square plus y square. We have the value of x is 50 and y is 120. So, we get the value of z square equal to 16,900. Let's square root 16,900. So, the answer of z is 130 feet. Now, we can calculate dz dt. So, we need to find the derivative of this question, which is z square equal to x square plus y square with respect to time. So the derivative of this question is 2z dz dt equal to 2x dx dt. dy dt is 0 because y is fixed and it doesn't change, it's constant. So let's divide both sides by 2 and replace z with 130 and x with 50. So dx dt is negative 20. Then let's divide both sides with 130. So we can cancel a 0 and we have 50 times negative 2, which is negative 100 over 30. So the final answer of dz dt is negative 100 over 30, or in decimal, negative 7.69 feet per second. So this is a rate of changing at the distance between player and the home plate.
So the conclusion is differentiation can help us solve many types of real-world problems. Second, derivatives to determine the maximum and minimum values of particular functions like strength, profit, cost, and loss. The last one is derivatives are met in many engineering and science problems.